Hello students, welcome back. Previously we went through some elementary problems of integration by parts. We went through these three problems. Now let's do this one. Is this also an integration by part problem? Well, yes it is. How do you see that? Well, we have a product of two functions, this times that, and that's about it. And if you take the derivative of the inside here, and it is just constant, so it's not going to be integration by substitution problem either. I mean, there's no other way. The problem is, it's not really that obvious what is u and what is v. I mean, they did not come directly from this hierarchy table. So how do we make it right? Good question. We have the integration by part formula here. U prime v. But then again, what is u and what is v in this case? To make a long story short, u is x squared plus 1, and v prime is the square root. Why is that? It is a bit tempting to get this one as v prime and this one as u because the growth order is lower for the square root function, 1/2 power, versus this one, second power. But this one is integer power, so if you take the derivative repeatedly, eventually it'll disappear. This one will never disappear. You see, each time you take the derivative, power goes down by 1, and if you start from 1/2 power, it'll go down to negative 1/2, and then after that, getting worse and worse and worse. So taking the derivative of the square root is highly inadvisable. Taking the antiderivative is not a fun job either, but it's better than the other way around. So okay, all right, v is that, v prime is, u is that, v prime is that, and take the derivative, u prime is 2x. V is, okay, what's this antiderivative? 2x plus 3 to the 1/2 power dx. What is this? Stop the playback and do it on your own. Add 1 and divide, so it's reciprocal. And then you need extra 1 over a, so 1/3. That's gonna be your antiderivative. Oh, excuse me, I forgot the equality sign. So this one here, green, to this green, that's a doable anti-differentiation problem. Much easier than this original. Okay, next, let's put everything into this integration by part formula. What's u, v prime? U is this, v prime is that, so let's just copy and paste. And then u times v, u is x squared plus 1, and v is, as you have over here, 1/3, 2x plus 3 to the 3/2 power. Okay, now let's go to 2x for u prime, and v is, well, 1/3, 2x plus 3 to the 3/2 power. Let's have a little bit of simplification because things are too complicated here. So let's take a bit of a break. X squared plus 1, and then 2x plus 3 to the 3/2 power. And then this integral becomes 2/3 x and 2x plus 3 to the 3/2 power. So what did he end up with? We have an integral, but that's too complicated still. So what do we have to do to this integral? Well, what choice do we have? We have another integration by parts. Nothing else, because you see, second power reduced to first power, that's a step up. If I do this again, it'll go down to 0 power. And any other technique, nothing applies. Inside is just a linear function, so integration by substitution will not work. Okay, all right, let's go ahead and do this. This is all set, nothing doing. And then, oh boy, what do we do with this? What's u and what's v? U is 2x plus 3 to the, no, what am I thinking? 2 over 3x. V prime is 2x plus 3 to the 3/2 power. You see, one more derivative, this will disappear. So u prime is 2/3, okay, all right. And v is 2x plus 3, and then add 1 to the power, 5/2, and then we have to divide, so 2/5, and then we need 1 over a, so 1 over 2, so that will become 1/5. And please note that this integral here, which I just highlighted in red, this one here, is the second integral that you have to do from here to there, green to green. And this blue, still too complicated, so split up once more by this red. And eventually what do I get? U times v. So u times v, so we have 2/3 x times 1/5, 2x plus 3 to the 5/2 power, and minus integral, but then again we have another negative sign here, so this becomes positive. And what is u prime? 2/3, and then v 1/5, 2x plus 3 to the 5/2 power. Okay, all right. Do we finally have a doable integral here? This one I'm talking about. Let me use another color, say purple. Okay, purple. Yeah, it's a power function, so we can handle it. These two are pretty much so set. And let's do this one. So 2/15 times 2x plus 3 to the 7/2 power, adding 1. And then we need to divide, so 2/7, and then extra 1 over a, so 1/7. Looks like this is the answer. Let's do just a little bit of simplification here. So 2/15 and this one here, 7 times 15, 105. I guess that's it. Yeah. Seven. Sorry, previous computation was right. My mental math was right, and then my typing in was wrong. Sometimes that happens. Usually the other way around, but this time it happened that way. Let's see, it's too complicated, so I better check. Let's see. What is Mathematicas computation? And of course, whether this and that are the same is difficult to tell, so let's take the difference and then simplify it. Copy and paste this thing and take the difference between Mathematicas computation and my computation and simplify, and the difference is 0. So two responses are actually the same. So that's it. Here goes the antiderivative computation of this using the integration by parts twice. First reduction, this uv prime to u prime v, so we have one antidifferentiation that's leading to first line, and then after simplification, second line. We still have one more integral to do, but that's too complicated, so we need another integration by parts. It's right here. uv prime to u prime v, especially this red, v prime to v, that's the second integration. And that leads to this line here. And this purple integral, okay, we can do that. And turns out to be this. And eventually that, adding all up, we get the answer. So basically, by applying integration by parts twice, we reduced this integration into 3 easier integrals. From green, v prime to v, and then red, v prime to v, and then purple, this one to that one. Okay, so much for this problem here. What did I do in my answer key here? Yep, integration by parts by ones. And then another integration by parts, and then in the end we got the same thing. And Mathematicas verification. I wrote a lot of lengthy explanations here, but essentially it's the same computation as the one I did earlier. Okay, all right, so much for the hardest problem here, and we have one more topic to go. See you soon.